Hi guys, welcome back to another video. We're still going through the KA Stroud Engineering Mathematics book and we're on the trigonometry chapter. So we're currently we just covered the trig functions last lesson. In this lesson we're going through the reciprocal ratios. Let's get started. In addition to the three trigonometrical ratios, there are three reciprocal ratios, namely the cosecant, the secant, and the cotangent, and then explain what they are. So cosec, sec, and cot. So obviously the reciprocal of something, so the reciprocal of 2 is 1 over 2, right? The reciprocal of pi is 1 over pi. So the reciprocal of sine is obviously 1 over sine. The reciprocal of cos is 1 over cos, and the reciprocal of tan is 1 over tan. These things, they have a name. We call the reciprocal of sine cosecant, we call the reciprocal of cos secant, and we call the reciprocal of tangent cotangent. Now, the way that I remember these, now it's a bit confusing learning which one is for which. Like if I ask you now, which is for which, can you remember? The tan one's fairly obvious, right? Cotangent is obviously for tan. Can you get the other two right? This one is for cot, and this one's for sine. Now the way that I remember it, I just look at the third letter of each one, and that will match up nicely with here. I don't know if that's an official thing, but that's the way I remember them. So just keep in mind that cosecant is just 1 over sine, secant is 1 over cot, and cotangent is 1 over tan. They've also put here that 1 over tan is the same as cosine over sine. Okay, so let's go over why cosine over sine is equal to 1 over tan. You may already know this, but tangent, tangent is equal to sine over cosine. Now, you may be thinking, what? Hang on a minute, how does that work? Let's go through it. So, remember SOHCAHTOA, right? So sine is what? Let's take this equation here that I'm saying is true. Let's replace it, right? So you've got tan is equal to opposite is equal to opposite, right? Over hypotenuse. Yeah? And then all of that divided by cos CAH adjacent over hypotenuse. Right? So maybe a better way to look at it, let's do this, right? So you got a triangle, you got A, you got B, triangle, and you got C, right? So here in this instance, A is the opposite, right? And this is the adjacent, and this is the hypotenuse. Let's just replace them with here. So we've got opposite is A over C. All of that divided by B over what? C. If you're dividing by a fraction, then you're also timesing by its reciprocal, right? So A over C, all of that divided by B over C is the same thing as, right, that's equal to A over C times C over B, right? Hopefully you get that. So whenever you're dividing by something, you're also, or you could alternatively be multiplied by the reciprocal of that thing, and it works out to be the same. Cool. So if we've got this now, then these two C's cancel out each other, right? And that leaves you with A, right, over B, correct? Now, if you remember, tangent is TOA, right? And what's TOA? TOA is opposite over adjacent, right? And so here, the opposite is A, right? Here. And adjacent here is B. So here you can see this is TOA, opposite over adjacent. So this is all basically a long-winded way. A over B is equal to TOA, right? And so this right here is TOA. Hence, it's tan. So this just proves this here. Tan is equal to sine over cos. So what we had in over here, what we have here is that 1 over tan is equal to cos over sine. So remember, the reciprocal of tan is what? 1 over tan, right? And we've already said that tan is opposite over adjacent. So obviously, so since tan is, as you can see up here, tan is sine over cos, right? So the reciprocal would just be cos over sine. So the value of these for a given angle, meaning the value of cosec, sec, and cot, can also be found using a calculator by finding the appropriate trigonometric ratio and then pressing the reciprocal key, the x minus 1 key. So here's the key here, just underneath mode. That's the x minus 1 key, the reciprocal key. So if we had 2 reciprocal, it's 0.5, or in fractions it would be half, right? Because obviously 2, the reciprocal of it is just 1 over that number. So if you did 8 reciprocal, it's 1/8. You did 9 reciprocal, 1/9, right? Fairly straightforward. So they want us to find the cotangent of 12 degrees, the secant of 37 degrees, and the cosecant of 71 degrees. Let's do that. So let's do tangent 12 degrees and then do the inverse of that. You can press the alpha key and then you can press, you see above the E and G it says cot, which is obviously for cotangent, then put in 12 and then we get the correct answer 4.7046. The other way to do it, which is the way that I prefer to do it, would be to just take the tangent of 12 equals and then to x minus 1 with the answer in there, and then you also get the answer 4.7046. So there's two ways you could do that. Second way, let's do secant now. Secant is obviously SEC, the third letter being C is cos, so we do cos 37 equals and take the inverse, and you got 1.2521, which is correct. And then we do the same again for cosecant. So cosecant, third letter being S, meaning sine 71, right? Then take the inverse of that, and you get 1.0576. So just explains it here again. Because 12, the tan of 12 equals 0.21255, and the reciprocal of that is 4.7046. So this is just talking about the method that we just did to do that, and it's the same for this and same for that. Let's move on. So to strengthen a vertical wall, a strut has been placed. A strut has to be placed 5 meters up the wall, right? So the strut placed here, and it's inclined at an angle of 43 degrees to the ground. So it's inclined downwards this way at 43 degrees. Okay. To do this, the length of the strut must be. So they want us to find out this length here, right? So how would we do that? If you remember in the last video, this is what we was doing. So let's just label what we've got here. So we've got the hypotenuse, right? Then we've got this, what's this one? The opposite. And we've got this one, the adjacent. So remember we have so, ka, so, right? So here we got the hypotenuse and the opposite. So we're obviously using so, right? Sine. So if we was to do sine 43 is equal to the opposite, which is 5 divided by L, you'd find that that wouldn't work. I suggest that you try it. We've done it previously above and also in other videos. So give on the previous video. Give this one a go and watch what happens. You're gonna find that it's gonna be a minus. So what we need to do is we need to use the inverse, the cosecant of 43. So let's inverse it, right? Let's do this. So what we'll do is we'll do 1 over sine 43 is equal to L over 5. Do you see what I just did there? What I inversed, I flipped here and here, and obviously flipped. So sine 43 is basically sine 43 over 1, right? Everything is always over 1. So I just inversed these two. So I've got 1 over sine 43 equals L over 5, right? Now let's work that out. So L divided by 5 is equal to 1 over sine 43. So what's 1 over sine 43? 1 over sine is equal to 1.4662, right? So then L is equal to 1.4662 times 5, right? So L is then equal to times 5, 7.33. And that you can see here. So what I do strongly suggest is I strongly suggest that you try solving it here. Sine 43 is equal to 5 over L. Try and solve that and you'll see that it will come out as minus. Now, the obvious reason why it can't be minus is because we're talking about what's the length of this hypotenuse here. Obviously, its length can't be minus. So it's going to be plus 7.33. And so they explain that here. Length of the strut divided by 5 is equal to 1 over sine 43, which is the cosecant of 43 degrees. L divided by 5 is equal to 1.4662. L is then equal to 7.33, which is times in by 5. Right. Main thing to remember here, if you do start solving it for sine or whatever, and you realize that actually, it's turned out to be minus, then just know that you've just got to inverse it and use the reciprocal, the cosecant, And just remember as well, the one way that I remember which one we're using is based on the third letter. Cool? Alright, I'll see you in the next one. Peace.